This lesson is for Advanced Algebra, Lesson 7-8 on negative rational exponents. This lesson is nothing new for students. This is just a combination or a culmination of a lot of the lessons that we've learned already in Chapter 7. We're just putting a lot of those ideas together. Yesterday, or in our last lesson in Lesson 7-7, we talked about powers and roots together as rational exponents. The only new piece we're adding today in 7-8 is the fact that those fractions may or may not be negative. If you do have a negative exponent, students should already know that that takes the base and flips it over. So that's why the x here, the base, turns into 1 over x in both cases. If you have a power on the top, that can be separated away from the bottom number, the root, and you can either do the root first and then the power, or the power first and then the root. I would recommend for students that they do the negative first, then the root, and then the power. Technically, students are allowed to do those 3 steps in any order they choose, but usually going in this order will be the easiest and fastest version. I want to clarify for students what it means if they're asked to simplify, because I think over the years there is an assumption made that students understand what simplifying means, even though it's not necessarily always explained. In these situations, you want to take care of any negative exponents, meaning if there is a negative exponent, you should get rid of it by flipping the base over. If there are any like terms, you want to combine them or deal with them in some way. And if there are any fractions, you want to try to combine them as best you can and then always reduce to lowest terms. So keeping that in mind, we've got 3 examples we're going to do first. We're going to start with some easy ones on the left and then progress to some more challenging ones on the right. Starting with 81 to the negative 1/4 power. Since the power is negative, the base, the 81, gets flipped over and changed to its reciprocal. Because the 81 is now on the bottom, if I just wrote the 1/4 without parentheses, it would be unclear if the 1/4 is with the 1 or with the 81 or both. So it is important for students to now incorporate an extra set of parentheses as soon as the base moves to the bottom. Remember that a 1/4 power means what times itself 4 times equals the base. So 1 is its own root, so we get a 1 on the top. 81, if we try to think about what number times itself 4 times equals 81, that number has to be a 3. If students didn't know that by heart, they would need to do some trial and error there to figure it out. Hopefully when you do your trial and error, your first trial and error number would be a 3, since this number is odd. You wouldn't do 2 to the 4th because that's never going to result in a number that's odd. So you would hopefully try 3 as your first guess. And when you do 3 times itself 4 times, you do indeed get 81. Moving on to the next example, if we have 125 to the negative 1/3 power, right away the negative tells us to flip the base over. So now we change that to 1 over 125. We put it in parentheses so that the 1/3 goes with both the top and the bottom number. 1 is its own cube root. 125 to the cube root, or to the 1/3 power, is the number 5. If students didn't know that, again, they would do some trial and error. This number ends in a 5, so 5 should be your first choice when you're doing trial and error. 5 squared is 25, and 25 times another 5 is indeed 125. Moving on to the third example, now we have a fraction base that's being raised to a negative exponent power. So the negative here is going to take the base and flip it over. So my fraction is now 1,000 over 27. Keep in mind here that the power does not flip, only the base does. Before I write 2/3 here, I'm going to take this fraction and rip it apart. The top number is going to be pulled off and held as a separate step. Once I pull the 2 off, a 1 takes its place, so I have 1/3 as my root, and then I'm going to do to the power of 2 later. I didn't have to do that on the previous ones because those had a 1 on the top already. This one we're going to do the cube root, or the 1/3 power, on 1,000 and on 27. What number times itself 3 times is 1,000? That's an easy one, that's just a 10. What number times itself 3 times is 27? Hopefully students know that that's not 9, it's 3. 3 times 3 times 3 is 27. Now we're done with the root portion, we still need to do the power. 10 squared is 100. and 3 squared is 9. Students may be tempted to go one more step here and write it as an improper fraction. Write it as a mixed number. It is an improper fraction, but you don't need to go ahead and write a mixed number. That would simply be more work, and more work then is necessary. So on our last example, we're going to follow the same pattern that we did on the previous. Start with the negative. That's going to flip this fraction over. And then we're going to take the fraction that's the power and we're going to separate out the 2 from the 5. So I put my fraction in parentheses. I've got 1/5 for my root, and then I still need to square. So the 5th root is a little bit trickier to handle or deal with. Students need to think about a number times itself 5 times that equals 243. It ends in a 3, so 3 would be my first guess. I have 3 to the 4th already memorized. I know 3 to the 4th is 81. So if I'm doing 3 to the 5th and I don't know what that result is, I would take 3 to the 4th and multiply by another 3. 3 times 1 is 3, 8 times 3 is 24, so that is indeed my answer. So I didn't know for sure. I did a little trial and error to find it. So 243 to the 1/5 power is 5. 32 to the 1/5 power is the same as finding what times itself 5 times equals 32. And I know that one by heart as well. That's a 2. If you didn't know that, 2 would be a good first guess. We still need to take that fraction and square it. 5 squared, don't say 10. 5 squared is 25. On the bottom, 2 squared is 4. Again, you don't need to write it as a mixed number. Improper fraction, as long as it's in lowest terms, is perfectly fine. We're also going to talk about solving for an unknown base. Again, we've done that before, students, so you should know what to do. If you're solving for an unknown base, you need to what? Use a reciprocal power. And going along with that, let's put in parentheses, make sure the base is isolated before you do that. Make sure the base is isolated. That'll come into play on one of our examples down below. So on this question, you'd be asked to solve for y. To get y alone, we'd want to raise to the reciprocal of the power that it's currently being raised to. If we don't make it negative, then we'll get a negative y here, and we don't want that. So when you're raising to a reciprocal power, you might need to bring a negative with. So we're going to say raise to the negative 5/3. Over on the left-hand side, we just get the y alone, because negative 3/5 times its reciprocal is going to be a 1. Over here, I'm going to right away, before I write my result, I'm going to flip the base. The base has a negative exponent, so the negative exponent's going to take that 1/8 and flip it over. I'm also going to take my fraction and I'm going to separate it out. The root and the power needs to be separate. I'm going to do the root first and then the power. So the cube root of 8 is 2. I know that one by heart. And then I still need to raise the 2 to the 5th. And 2 times itself 5 times, I know is 32. If you didn't know that, you shouldn't guess. You should go ahead and work it out. So when the power is a negative, you flip over the base. And we got that power by using a reciprocal power to solve. We're going to do similar method over here on our last example. However, on this one the base is not isolated. There's a 3 in our way. We need to deal with the 3 before we can deal with the reciprocal power. So don't assume that you're always going to do reciprocal power as your first step. Usually it'll be your last step if there's other things happening. The 3 is being multiplied by the x, so to undo it we're going to divide. So 27 divided by 3 is 9. Now to get rid of the fraction power here, to get the x isolated, I'm going to raise to the reciprocal power, negative 5/2. On the left-hand side, the powers are going to cancel. Over here, I know I have a negative exponent, so right away that base number of 9 flips over and becomes 1/9. I'm going to take the fraction power and separate it into a half, and then the power of 5. So remember that a half power is the same as taking the square root. Square root of 1 is itself. Square root of 9 I know is 3. And then I still need to raise that to the power of 5. So I know 1 to the 5th is still 1. 3 to the 5th, I did that earlier, so I know that that's going to be a 243.